Good morning, class. Hello, everybody. We're going to tackle a section from this chapter, 7-3 is the section, called Solving Equations Using Quadratic Techniques. Now, what that's referring to, basically, is that some functions can be solved if they have an appearance of a quadratic equation. Now let's review what a quadratic is. A quadratic function or a quadratic equation is of this form. And if we see something in this form, we can solve it using the 4 or 5 techniques that we've looked at in the past. One of them would be factoring. One of them would be using the square root property. One might be well, number 4 is the quadratic formula, and one of them is the graphing technique. You can graph it and solve it using the graphing technique. Now, usually we kind of concentrate on these 4 or these 3, particularly because they're easier to use, but quadratic formula is a fail-safe. It always works. Sometimes it takes more time, but it will always work. Some of these other techniques are maybe sometimes a little difficult to get to work. They do work, and sometimes they're faster, but the quadratic formula is a good technique that always works. Now, if we're going to solve something that's in this form, it might look a little different. Let me show you what one might look like. Okay. Now here is an equation where it is in the quadratic form, but it doesn't look like it's x to the second power. Now, what does that mean? Well, notice that up here in the form, this exponent in the middle term is a 1. So the middle term exponent is half of the leading exponent. And when that occurs, that is quadratic form. Okay? And notice here, this exponent is half of this one. So also if I had something like t to the 6th plus 5t to the 3rd minus 7, this is also in quadratic form because the exponent in the middle term is half of the lead term. Or how about this one? W to the 8th plus 5w to the 4th equals 0. Even though there's not a third term, the middle term here is half, the exponent is half the leading term. So these can be solved using quadratic techniques. Now I'm going to show you 2 ways to do this. The book kind of focuses on one way, and I like a different way, and I'm going to show you both of those. So let's start with this first one here. Well, what the book typically does is says, let's take and rewrite this so that this middle term is kind of separated, and we're going to call it 13x squared parentheses to the first, and up here let's call this x squared squared. And they're going to say, oh, let's see here. Oh, this is x squared squared. Well, notice that the exponents now are 2 and 1 here, and they would solve this by factoring. Now, if this is a little bit confusing to you, well, it is to me too. And so I have another method that I typically like to use, and I'm going to encourage you to use it. What I do is something that typically works very well. Let's let some letter, I'm going to pick a letter, let G, or for example, I'm picking that letter, to represent this item in the middle, this middle term, the variable portion of it. Let G represent x squared. Now, let's rewrite the equation using G now instead of x squared. Well, x squared squared is x to the 4th, so this is actually G squared, and this is 13G, and that still brings down the 36. Notice x squared has been turned into G, and x to the 4th would happen to be G squared. Now, looking at this is much easier now to factor or use the quadratic formula. And we're going to do that. I can see that this will factor. What are the two factors of 36 that give me 13 when I add them together? It turns out to be 9 and 4. So I'm going to skip to the kind of the end of this. This is g plus 9 times g plus 4 if I factor this, okay? I mean, I could use one of these other techniques possibly as well, quadratic form maybe. And this happens to be the factored version of this. Now, at this point, I can solve this, and I find out that g is equal to a negative 9, and g is equal to a negative 4. Okay? So there are the two solutions to this. However, since this is an x to the 4th polynomial, I may expect, in fact I should expect, 4 answers. Well, these g's are not really part of my original problem. I'm going to now take this and resubstitute it back in. X squared is equal to negative 9, and x squared is equal to negative 4. And as we look at this now, this has got 2 answers, and this has 2 answers. I'm going to run up to the top here and put that in up here, okay? Let's go back up to the top here. If x squared is equal to a negative 9 and x squared is equal to a negative 4, let's solve this. Well, take the square root of both sides, and we get x equals plus or minus. Now, if you recall that that's going to be an imaginary answer, this is 3i. And same thing over here. Take the square root of both sides, and we get x equals plus or minus. Remember, when you take the square root of both sides, you have to take the plus or minus on the right side there. And the square root of negative 4, again, is going to involve I. That's 2i. Now, what you've got here is actually 4 answers. Plus 3i, minus 3i. Plus 2i, minus 2i. There are 4 answers. And the reason there are 4 answers is because this exponent is a 4. You will always get the same number of answers that you have on the highest degree. Now, we never would have seen that if we just would have stopped here. We think, oh, our answers are these two. But we got to put x squared back in, and then we can go ahead and figure out what all of our answers are. Let's try another one of these. All right, we're going to solve this. And the first thing we want to check to see is if this is in the quadratic form. Well, I notice that the middle term's exponent is half of the leading term exponent. So yes, this can be written in quadratic form. And I could do it like the book does, but what I'm going to do is I'm going to let some letter, let's call it g again, be equal to this middle thing here, which is x squared. Okay? That means if the middle term is g, the first term has to be g squared. Now it's easy to see that this is a quadratic. The middle term is half, the exponent is half of the leading exponent. Now I can factor this or use the quadratic formula. I think I'm going to factor this again. This turns out that this factors, the two factors of 100 that give me negative 29 would be negative 25 and a negative 4. So my factors, I'm going to just kind of skip to the end, is g minus 25 and g minus 4, and that's equal to 0. Okay, so I've factored that. I could have used the quadratic formula or anything like that. But now I've just found g. Okay, well, g is not really what I want to solve for. I'm trying to find x. So we're going to take this and stick it back in here in both places for g. There's one, and there's the other. Now this quadratic technique works when we have a term where the middle term is half of the exponent is half of the leading term. Now let's solve these two, and then so I'm going to set each one of these equal to 0. Remember, we're using the zero product property to do this. Well, this turns out that I can factor this or use the square root property. This turns out to be x plus 5 and x minus 5. Okay, so it's x plus 3 and x minus 3, oh, excuse me, 4, x plus 2, and x minus 2. Okay, these are both the difference of squares, so that's how I knew to factor these quickly. And now we're going to set each one of these equal to 0. And make a long story short here, x is equal to a negative 5, x is equal to 5, x is equal to a negative 2, and x is equal to 2. Notice 1, 2, 3, 4 answers, and that's what we expect because the problem is x to the 4th. We should expect the same number of answers as our leading exponent. Let's try another one here. All right, here's a problem that looks a little funny, and what you'll notice is it doesn't have a middle term here. But I can stick one in just so we can see what I can stick one in if I just call it 0x cubed. Now, why would I do that? Well, because now I can see that the middle term has an exponent which is half of the leading term. So I'm going to write this using quadratic technique and that let statement we have. Let's let g be equal to this guy in the middle, x cubed. So what I've got is 0g and up here in the front, if x cubed is g, then x to the 6th would have to be g squared. So there it is. Okay, g squared is the same as x cubed squared, or x to the 6th. Now this guy here happens to be the difference of two squares. If I ignore this in the middle, I see the difference of squares here. Oh, 625. The square root of both, these are both perfect squares, and there's a difference in the middle. So this would have to be 4g plus 25 and 4g minus 25. 25 times 25 is 625. Okay, now I've got it to this point. Let's substitute back in this guy. We're going to stick it back in here. X cubed plus 25, excuse me, 4x cubed plus 25, and 4x cubed minus 25. Okay, well, this one's factorable. This one we can solve using the cube root property, and we're going to do that here, but this one, this is supposed to be cubed here. Okay, this is not the difference of squares, and we can solve both of these using the cube root property. So what I would just do is, okay, if we set it equal to 0, and then go ahead and move the 25 over to the right and divide by 4. We're using up a lot of paper here, aren't we? Divide by 4. I'm out of room, but now I can take the cube root of both sides, and I will end up with some answers that happen to be duplicates, in fact triplicates. So it can be done to solve these. Let's look at another one that's a little odd. Okay? All right. Now, it's been a while since you've actually had to work with fractional exponents, so let's do a little bit of review on that here. We're going to spend some time kind of looking at how to deal with fractional exponents, but for the moment, we don't need to worry about it. I'm going to just notice that this middle exponent is half of this one. 1/3 is half of 2/3. So I'm going to take this one, and I'm going to write myself a let statement. Let's let g equal to x to the 1/3. The 1/3. And let's rewrite this using g now. Well, this middle term would be negative 6g. And the first term is got to be g squared. X to the 1/3 squared, I multiply the exponents, I end up with 2 squareds. That's right. So now I can see that this is, in fact, a quadratic form that I can factor. In fact, we can factor this. The two factors of 5 that give me negative 6 when I add would be negative 5 and negative 1. So let's just jump to the end. G minus 5, G minus 1, product is 5 and the sum is -6. So we find that g is equal to 5 when we solve this, and g is equal to 1. I skipped through the zero product property. Now, if this is what g is equal to, let's resubstitute back in here, and let's put x to the 1/3 in here instead of g. X to the 1/3 instead of g. Well, how do you solve with fractional exponents? This is a little bit of a review. What does this 1/3 mean? Well, it means the cube root, doesn't it? It means the cube root of x. Well, how do you undo a cube root? Well, you cube it. So I'm going to cube both sides. By cubing both sides, x now is going to get alone. Remember, if you have powers of powers, you'd multiply exponents here, which gives us x to the first, which is x. So one of the answers is 125, and same thing happens over here. The other answer is 1 cubed, which is 1. Now we don't get we don't necessarily get several answers. We might get one answer, but in this case we ended up with two things that would work for x in this situation. Sometimes solving these with fractional exponents is kind of a slick way to do this. I would encourage you to use the let statement approach rather than the way in which your book tries to write it. Let's do one more and then I'll cut you loose. All right, here's another one, and this is not a quadratic, but it can be solved using quadratic tools. First of all, let's set it equal to 0 here. So we're going to move the 7 over, subtracting from both sides. And I look at this middle term and I realize that exponent is half of this one. You say, well, what is the exponent there? Well, isn't this 6x to the 1/2 power? The square root is the same as the half power. So let's just rewrite this using fractional exponents. Remember I told you at one point that fractional exponents are sometimes easier to understand than roots, than radicals. So the square root of x is the same as x to the 1/2 power. Now you can clearly see that the exponent in the middle is half of the leading exponent. So let's use our let statement. Let g equal this middle guy here, okay? X to the 1/2. And we'll rewrite the problem. This is my -6g minus 7. And then this one, the exponent would have to be twice this, which becomes g squared. Okay? X to the 1/2 squared is x. Okay? The square root of x squared is x. Okay? So what are the factors of this? Well, the factors that give me -7 when I multiply and -6 when I add, that would be a -7 and a +1. So let's rewrite. I'm just going to go ahead and jump to the end on this. G minus 7, G plus 1, and there's the factored version of that quadratic. And when we solve this using the zero product property, G is 7 and G is a -1. Now let's go ahead and plug x squared back in for g. So I get, x to the 1/2 power. I'm going to write this in exponent with a fraction, but I could write it with a square root if I wanted to. Okay. Now, how do you undo x to the 1/2 power? The square root, right? We will square both sides. So I'm going to square here, and here, and here, and here. What do we end up with here? Well, x to the 1/2 squared is just x, and this is 49. And x to the 1/2 squared is x, and -1 squared is 1. Now this concerns me a little bit that I've now gotten rid of that negative. I wonder if this would actually work in the original problem. We haven't talked about that yet today, but it's probably a good idea that you double check these back in the original. In fact, we're going to check this 1 up here, and see what happens. Okay, so I'm going to take this clear back up to the top. X is 1 minus 6 times the square root of 1. Is that equal to 7? Well, 1 minus the square root of 1 is 1. 1 minus 6, is that equal to 7? No, that didn't work. That one didn't work. Just to check it out also, let's try 49 in there. Okay, we're going to try 49. So that would be 49 minus 6 times the square root of 49. Square root of 49 is 7. 6 times 7, I got 49 minus 42. Is that equal to 7? Yes, it is. So this one worked. Square root of 49, or 49 worked for one of our answers. So as you can see, especially when you square both sides of something, you need to make sure you check those answers at the end. All right, so give this a shot. Take a look at this. Remember, you should get answers. Let's do one more. I got one more idea for you that I'd like you to look at. All right, this is not necessarily the same techniques as before, but it does bring us back to understanding a couple things that we haven't seen in a while. This is x to the third, and I should expect 3 answers in my problem. Now, as I look at this, I realize that I cannot take an x out of every term, but if you recall, this has that look to it that looks like factoring by grouping. Look at the ratio here is 1 to 4. -1 to -4. I bet you this can factor by grouping, and let's try that. So I'm going to underline both groups. On the first group, let's take out x squared, and that leaves us with x plus 4. Going to copy the leftovers over here. Copy those leftovers. And what had to come out of the second group to give me this? Well, it was a -1. -1 had to come out. So now let's marry the pieces together. X squared minus 1 times x plus 4. We basically unfoiled that thing, didn't we? Okay, now as I look at this one we can solve pretty readily. X plus 4 equals 0, or x is equal to a -4. But this one actually can be factored. I recognize that as the difference of squares. X plus 1 and x minus 1. So if we solve this, we find out, I'm going to just jump to the end, x is a -1, and here x is a +1. So you'll notice we got 3 answers, which makes good sense because we ought to get the same number of answers as that highest exponent. Now that works for numbers greater than 1 or greater. Doesn't necessarily work for fractional exponents. All right, here's your homework for tonight. All right, here's the assignment that goes along with this lesson today. Number 53, page 462, and 463, I guess it is, page 463. 4 through 10, and you're going to use quadratic techniques. They're going to ask you at the beginning to determine if it can be written in quadratic form, so just use a let statement to do that, or you can use the technique they show you in the book. All right, enjoy that, and I'll see you next time.